Hello, this is William Wagesback. I'm a sophomore student at the University of Louisiana at Lafayette studying mechanical engineering, and this is my MCHE 201 final project individual contest. This presentation will contain an introduction where competition details and the objective is stated, specifications which includes the track dimensions, device specifications, and a cost analysis of materials, and a video section which displays the track and device dimensions, the trigger device, an attempt, and finally a conclusion. This year's theme for the final project in the spring of 2026 is Harry Potter, the Tri-Wizard Tournament. The objective is to create a device that allows 3 Lego men to safely cross the team zone into the elevated maze. For the specifications outlined in the handout, the start zone is a 2x2 foot box, and the distance from the start of the start zone to the beginning of the hedge maze is 22 inches. The hedge maze is 6 inches tall and is 2 foot by 2 foot in length and width, and the maze center platform is 12 3/4 inches tall and has a 6-inch radius. This can be seen in the 2 figures on the right side of the presentation. The device must be contained within the start zone. It cannot use any forms of stored energy other than gravity. The trigger for the device must be contained within the start zone, and it must remain static while being undisrupted, and costs less than $100 to make. This is the bill of materials with a cost analysis. I used about 94 inches of treated 2x6, which is slightly less than 8 feet, and that costs about $15. I used one 6-inch long 3/8 inch bolt that was the pivot point of my lever arm, which costed about $4. I used about 12 to 18 inches of nylon yellow string that cost about 65 cents. I used 5 feet of 1/2 inch conduit for my lever arm, and that costed about $4. I used about 4 inches of 1/2 inch angle iron for my basket for my Lego people, and that costed about $1. And this totals to roughly $25. These costs were determined by cost per foot of material. This was found by looking up the materials on Home Depot and using a basic ratio of cost per foot to X number of dollars per foot to determine the cost at the length of each material used. Alrighty, so for the dimensions of the track, we have the start zone to be a 24-inch box that we can see right there. And we can check the other side as well to be 24 inches. And then the width of our team zone to be 68 inches. And then the start of the team zone to the start of the hedge maze, we get that to be 22 inches. And then from the start of the start zone to the center of the platform, we get that to be 34 inches. The width of the hedge maze, we get that to also be 24 inches. And we can verify the other side by checking it as well. 24 inches. And so then we get our height of our platform to be just over 12 3/4. And we can verify that by checking the other side as well. Just over 12 3/4. And then the diameter of our platform is 12 inches. And now for the dimensions of the device. So the device is fully enclosed within the 2x2 box of the start zone. We can see that the device's overall length is right around 23 inches. At the device's widest, we have it to be 7 3/4. And the height of the 2 vertical pillars are just at 24 inches. And then to further prove that this tall lever arm is also within the 2x2 box, I have the string hanging over the furthest point of the lever arm hanging straight down by a nut, and you can see that it is fully inside of the team zone by almost 7.5, 8 inches. The device is triggered by cutting this wire, allowing the arm to release the 3 Lego men into the landing zone. And as you can see, that this is still very much within the box. And now for the performance of the device. And as you can see, all 3 Lego people made it safely. The individual competition required one to create a device that carried 3 Lego men safely to a predetermined location only using gravity. The specifications of the device and the dimensions of the track layout were stated. The videos show you that the device and the track layout adhere to the dimensional and spatial requirements provided by the project handout. And the last video proved that the device is functional by displaying it in action. Thank you.